Welcome to our YouTube channel, where we delve into the fascinating world of pressure sensors and their crucial role in enterprise maintenance. I'm Ryan Chan, the CEO and founder of Upkeep. In this video, we're going to take a journey from the origins of pressure measurement in the 1590s, all the way to the present day, exploring the evolution of pressure sensors and their real-world applications. We'll be shedding light on how these devices work, how they can save your business time and money, and even give you the power to predict and prevent breakdowns. Let's get started. Let's take a journey back in time to the 1590s, when people first became fascinated with measuring pressure changes. They started with simple glass tubes and barometer experiments, measuring how much the fluid inside was pushed or pulled by pressure changes. Fast forward to the present day, we've come a long way from measuring the rise and fall of fluids in tubes. We now understand the effects of pressure changes on the physical and electrical properties of materials. And thanks to highly advanced pressure sensors, we can measure pressure fluctuations with astounding precision and accuracy. So, what exactly is a pressure sensor? Well, it's a device that senses and measures pressure, which is defined as the amount of force exerted over an area. These devices collect real-time data on the conditions of equipment, and based on this information, they can predict and prepare for failure patterns. By installing pressure sensors to certain tanks and other pressurized assets, the sensors can alert maintenance teams when the pressure falls outside of a specified level, allowing the teams to address the issue immediately. But how do pressure sensors work? Well, they measure a physical change that happens as a reaction to pressure differences. After measuring these physical changes, the information is converted into electric signals. These signals can then be displayed as usable data that the team can interpret. Here's how this process works in 4 simple steps. First, a strain gauge converts pressure to electrical signals. The most common type of pressure sensor uses a strain gauge, which is a mechanical apparatus that allows small expansions and contractions as pressure is applied or relieved. The sensor measures and calibrates the physical deformations to show how much pressure is put on a piece of equipment or tank. Then, it converts these changes into voltages or electric signals. Second, these electric signals are measured and recorded. Once the sensor produces an electrical signal, the device can record a pressure reading. These signals increase or decrease in intensity, depending on the pressure felt by the sensor. Depending on the signal frequency, pressure readings can be performed between very close time intervals. Third, your computerized maintenance management system receives an electric signal. The electrical signals are now in the form of a pressure reading, in units such as pounds per square inch or pascals. The sensors send out the readings, which are then received by your computerized maintenance management system in real time. With multiple sensors installed throughout various assets, a computerized maintenance management system acts as the central hub to keep track of the whole facility. And finally, the computerized maintenance management system alerts maintenance teams. With sensors in place, your maintenance teams get alerted when a pressure measurement is too high or too low. Pressure ratings that are too high can indicate a risk of parts rupturing or a chance of damaged equipment. On the other hand, a loss of pressure can be a sign of leakage, especially on pressure vessels. Now let's delve into the 7 types of pressure sensors. These can be categorized according to the method they sense pressure changes. They observe and measure various physical reactions. The most common types are strain gauge, piezoelectric, capacitive, manometers, vacuum pressure, Bourdon tube, and aneroid barometer. Pressure sensors have a wide range of applications in your facility. They are used for monitoring pipeline or hydraulic hose pressure, setting norms for electronic transmitters, measuring low to high vacuum pressure, conserving energy, and in technology and manufacturing industries. The beauty of pressure sensors is that they can save your business time and money. They provide you with the power to look into the future and come up with a maintenance plan in time to prevent breakdowns from occurring. This is essentially what pressure sensors, as tools in predictive maintenance, are trying to do. They don't stop at sensing pressure changes. They make the information useful by sending the data to your computerized maintenance management system. This allows you to get a bird's-eye view across autonomous parts of your facility. By having sensors that send real-time data, your maintenance team can be notified at the onset of any unusual behavior. Having a predictive strategy in performing maintenance really pays off. In fact, the U.S. Department of Energy estimates roughly 8 to 12% savings over preventive maintenance, and up to 40% savings over reactive maintenance. Think of these savings as an added bonus on top of huge safety benefits and increased reliability. In conclusion, most modern facilities are dependent on equipment that use highly pressurized vessels. Equipment breakdown can cause catastrophic failures due to the high energy that they store. Pressure sensors help to identify risks early by notifying the maintenance teams of any anomalous deviations from ideal working conditions. Combined with a predictive maintenance strategy, sensors allow maintenance teams to perform corrective action before any failures occur. Thank you for watching this video. We've explored the world of pressure sensors, their evolution, how they work, and their real-world applications. We've also discussed how they can save your business time and money by predicting and preventing breakdowns. If you found this video informative, please subscribe to our channel. For more resources and tools to help maintenance and reliability teams be more successful, visit our website at upkeep.com.